last method that we've seen to solve a system of equation is by elimination. This time, if we look at the two equations, so this one and the red one here, 3x minus y equals to minus 5, none of our terms, or none of our variable terms have the same coefficient. Okay, so here I have negative 2x, here I have 3x, here I have 3y and minus y. So we have an extra step to do in the method of elimination. Okay, so first of all, we're just going to call this equation equation 1, call this one equation 2. Okay, so I'm just going to leave these here for now. Now, if we look at equation 2, what do we have to do to equation 2 so that we can get a similar term as in equation 1? Okay, so if I look at my term with y here, I have minus y and 3y. If I had minus 3y down here, then I would be able to solve this by elimination. Well, I can do that. I can multiply every single term in equation 2 by 3, and that's not going to change my equation. Okay, it'll just change the way it looks, but it will still be the same equation. So if I take equation 1 and equation 2 here, equation 1 stays the same. Equation 2, I'm going to multiply every single term by 3. We're going to end up with this. Okay, equation 1 is the same. Equation 2, I had 3x, so I'm going to multiply that by 3. That's going to give me 9x over here. Okay, so that comes from my original 3x times 3 gives me 9x. Then my minus y times 3 gives me minus 3y. And then my minus 5 times 3 gives me minus 15. Okay, why did we do that? We wanted to have these two terms here similar. So I have plus 3 minus 3. Okay, so if I look at these two, those are the two terms that I'm going to use here in the method of elimination. Okay, so if I add the two equations together, in this case we choose an addition because I have plus 3y. So plus 3y plus minus 3y. That's the same thing as saying 3y minus 3y. That's going to give me 0y. That's what I want. Okay, so you choose the sign, positive or negative, so that what you get down here is a 0. Okay, and so for our example, we use plus. So now I'm left with minus 2 plus 9x will give me 7x. 3y plus minus 3y is 0. 8 plus minus 15, that's 8 minus 15, it's minus 7. Okay, so that's the same thing as saying 7x is equal to 7. So I want to isolate the x. I will divide both sides by 7, and we will end up with x is equal to negative 1. I'm going to highlight this. This is part of our answer. We still need to find the y. So we're going to use the method of substitution. I can substitute this x into either equation 1 or equation 2. So in this case, it's easier to substitute it into equation 2 because my y is already almost isolated there. So I have 3x minus y equals to minus 5. This is equation 2. We took that from here. That was our original equation. Okay, I substitute the x with negative 1. Okay, we just found that out, that x is equal to negative 1. And so that will give me 3 times negative 1 is minus 3. Minus y is equal to minus 5. We leave the y, or the negative y, alone on the left side of the equation. So we isolate the negative y by subtracting, by adding 3 on both sides. So we're left with minus y is equal to minus 5 plus 3. I divide everywhere by negative 1. Okay, before I do that, minus 5 plus 3 we know is minus 2. Now we're going to divide everywhere by negative 1, so that I end up having y is equal to 2. And that is the last part of my solution. Okay, we have our answer. The point of intersection is minus 1 2.